Section 4.1, Exponential Functions, Part 1. Our first session in our virtual classroom. New to me, I'm not sure if it's new to you, but we're going to get through this. If you happen to hear dogs barking in the background, I have 2 dogs, so hopefully you'll get a chuckle. Okay, Section 4.1, Exponential Functions. How do we recognize if a function is exponential? One thing that we look for first is the variable in the exponent. If we have a variable in the exponent, then we have an exponential function. When we look at the base A is going to be a constant. A constant is just a number. For example, 2. Base constant 2 raised to a variable exponent x. 2 to the x is an exponential function. A constant 3, so we have base 3 raised to a variable exponent x. 3 to the x is an exponential function. 10 to the x, an exponential function. This is what exponential functions look like. First thing that we're going to do is we're going to look at graphing an exponential function. When we graph exponential functions, first thing that we want to look out for is our base A. If our base is greater than 1, what that means is that we're going to have a graph that increases. As I trace this graph from left to right, we see our graph. As I trace from left to right, we see our graph increasing. Okay, again, looking at our base A. If our base A is in between 0 and 1, what we learned from before is that this is a common way in math that we write fraction. Think of 1/2. 1/2 is between 0 and 1. 1/2 is a fraction. 1/4 is between 0 and 1. 1/4 is a fraction. If we have a base that's a fraction, then we're going to have a graph that decreases. As I trace left to right, our graph decreases. As I trace left to right, our graph decreases. Now, does it ever touch or cross the x-axis? The answer is no. Y equals 0, the x-axis is a horizontal asymptote. Asymptotes are guides for which a graph approaches. For exponential functions, it's going to approach the x-axis but never touch or cross. We're going to approach the x-axis but never touch or cross. Okay, what else can we say about exponential functions? Domain is all real numbers. Automatic. So if I have an exponential function, the domain is from negative to positive infinity. Range, remember that's your y values. If I look at the range, since we never touch or cross the x-axis, the range starts at 0 and goes to infinity. This will be the case as long as we don't have a transformation, shifting the graph up or down, or reflecting on the x-axis. Okay, so let's look at maybe a couple of examples. Our first one here is going to be y equals 3 to the x. Y equals 3 to the x. What's our base? Our base is 3. 3 is greater than 1, so we're going to have a graph that increases. As I trace left to right, we see our graph increasing. To get detail in our graph, we're going to pick a few x values, plug it in to get y. For exponential functions, I like to pick -1, 0, and 1. You can pick any x that you want. These are just the 3 that I like. Okay, 3 to the negative 1, that negative exponent sends the 3 to the denominator, so we would be plotting negative 1 1/3. 3 to the 0 is 1, we would be plotting 0 1, and then 3 to the first is 3, we would be plotting 1 3. Okay, so negative 1 1/3 is right here. 0 1 is here. 1 3 is here. And if I increase, we see that 3 to the x graph that was already given to us. Okay, let's look at our next example. Our next example is 1/3 to the x power. Okay, so 1/3 to the x power. What is our base? 1/3. That is a fraction. So that means our graph decreases. As I trace it from left to right, our graph decreases, approaching the x-axis as a horizontal asymptote. Okay, again, we're going to get a little bit accurate on our graph. We're going to pick some x values. We can pick whatever x values we want, and then we're going to plug it into 1/3 to the x power. I like to pick these three, but you can pick whatever you want. 1/3 to the negative 1, our negative exponent, flips our fraction. 1/3 becomes 3. So we would be plotting negative 1 3. 1/3 to the 0 power would be 1. We would be plotting 0 1. 1/3 to the first would be 1/3, so we would be plotting 1 1/3. Okay, so negative 1 3 is here. 0 1 is here. 1 1/3 is here. We know our graph is decreasing because our base was a fraction, and there would be our graph. Okay, so just some basic properties of graphing exponential functions. And before we go on this one, what I wanted to also point out is, notice this point was common for both graphs. If I take 3 to the 0, I'm going to get 1. So that's going to go through 0, 1. If we take, like we did above, 1/3 to the 0 power, we're going to get 1. That's another property that we're going to add to our list. Domain, negative to positive infinity. Range, 0 to infinity. X-axis, horizontal asymptote. And our graphs, whether they're increasing or decreasing, go through that point 0 1.